For nearly 13 years, FluorHanford, an operating unit of Fluor Corporation, worked at the Department of Energy's DOE's Hanford site to clean up the legacy of hazardous and chemical waste generated from producing nuclear weapons. The effort is the largest environmental restoration project in the Western Hemisphere. From August 1996 through August 2009, Fluor was the prime nuclear waste cleanup contractor at Hanford, which sits in the desert of southeastern Washington state. During those years, FluorHanford brought cleanup a long way, completing complex and challenging projects, making the site and the region much safer and protecting the magnificent Columbia River, a natural resource of immense importance to the Pacific Northwest. The legacy of waste from nuclear weapons production is neither simple to describe nor easy to address. Hanford contains approximately 2/3 of the Department of Energy's nuclear waste. It exists in many forms. For example, uranium that has been irradiated in nuclear reactors is called spent fuel and is highly radioactive. Hanford has 80% of all the spent fuel in the nation that was produced for government projects, including nuclear weapons. Further, Hanford has more than 50 linear miles of solid waste contaminated with radioactivity, packed in various drums and containers and buried in trenches underground. And at a highly secure compound near the center of Hanford, a 15-acre complex of 63 buildings held vast amounts of plutonium, one of the most deadly substances on Earth. In addition, Hanford has 177 huge steel tanks that contain approximately 53 million gallons of the most toxic liquids in the world. From the surface, all one can see are small pipes protruding from the tops of the massive tanks that are buried underground. Perhaps the most challenging aspect of Hanford is the approximately 100 square miles of groundwater that is contaminated with radioactive materials and chemicals. Extensive efforts have been and continue to be made in preventing the contaminants from seeping into the Columbia River, which flows through Hanford for 51 miles. Hanford also has other hazards, including more than 1,000 excess buildings, many of which are contaminated with uranium, plutonium, cesium, and strontium, as well as dangerous chemicals like asbestos and beryllium. All of these risks existed on the Hanford site when Fluor began major waste remediation and site maintenance work in 1996. For many of the chemical and environmental issues, there were no plans for dealing with them. They had never been addressed before. When Fluor arrived, Hanford's remediation activities were primarily a paper exercise. That means that environmental engineering studies about waste and cleanup concepts were in process, and very little physical restoration of the facilities and land was being completed. However, Hanford's cleanup had recently been planned and codified in a legal agreement referred to as the Tri-Party Agreement. It is officially called the Hanford Federal Facility Agreement and Consent Order, and was signed by the DOE, U.S. Environmental Protection Agency, EPA, and Washington State. Progress in the Tri-Party Agreement, or TPA, is measured in milestones. Under FluorHanford, true cleanup work began in earnest on many fronts, and TPA milestones began to be met. Today, the fruits of labors begun or completed by Fluor have changed the face of Hanford. Among the first and highest DOE priorities that Fluor addressed were the K basins. The K East and the K West basins were two enclosed concrete pools attached to nuclear reactors that were no longer operating. They contained the largest collection of spent nuclear fuel of any DOE site in the nation. Each basin held about 1.2 million gallons of water. After the fuel came out of the reactors, it was put into the basins to cool, to allow the radioactive constituents to decay and reduce the level of radiation. The basins were located just a quarter mile from the Columbia River and were more than 40 years old when Fluor arrived. Their structural integrity was very questionable, and they did not meet modern codes and standards. Fluor designed and installed new equipment in the old K-basins to grapple, wash, package, and remove the fuel in large, sturdy steel casks. The process was tedious. Workers had to bend over railings 20 feet above the K-basins and reach into 16 feet of water using long-handled tools to manipulate the very radioactive fuel. The tasks were doubly hard because the water in the K-basin was so cloudy that workers had to use remote cameras to see what they were doing. Despite the difficulties, in 2004, Fluor finished removing all of the spent nuclear fuel from both K-basins, 2,300 tons of material, representing 55 million curies of radioactivity. A curie is a measure of radiation. 55 million curies represents a huge amount of radiation. Hanford is one of the most contaminated places in the world, and the 55 million curies in the K-basin's fuel represents about 15% of all the curies at Hanford. To handle the fuel after it was removed, Fluor built and equipped 2 new facilities. The first dealt with drying the fuel using a first-of-a-kind drying process to extract the water. The second facility was designed to store the dried and packaged fuel in underground steel tubes. Fluor situated the canister storage building in the central part of Hanford, miles away from the Columbia River. Even after the fuel had been removed, Fluor faced another extremely hard task in the K-basins. The nuclear fuel had corroded or degraded over the years of its storage underwater. The corrosion contributed to the formation of sludge, a combination of rust, dirt, sand, chemicals, and very radioactive materials. The sludge coated the K-basin's walls, floors, tools, and equipment. Some of the sludge had accumulated in areas of the basin as hard, compacted layers. The majority, however, was suspended in the water as fine particles. Capturing the sludge as it swirled through the basins was very challenging for the operators as they vacuumed the flighty material into underwater tanks. One person characterized the work as chasing smoke. The sludge didn't go where we wanted it to go, didn't behave as we wanted it to behave, and didn't stay where we wanted it to stay. Because the K-basin had leaked radioactive water in the past, Fluor's plan was to empty that basin first so it could be removed and the ground underneath remediated. Therefore, the K-West basin was equipped with special holding tanks for the sludge from the K-East pool. Fluor constructed and operated a specially engineered system to move the sludge. Pumping the K-basin sludge through this hose-inside-a-hose arrangement was a first-of-a-kind operation using unique technology. The activity was especially difficult because the sludge was not uniform, with some parts stickier than others. After a multi-year campaign, Fluor workers claimed victory in 2007 as they vacuumed up the last of the sludge. The achievement was significant because the sludge had posed the greatest threat of escaping into the environment. With this aspect of the project completed, 2 million people down the Columbia River were safer. As they vacuumed the sludge, FluorHanford workers also removed large amounts of debris. Debris was solid nuclear waste and included equipment, tools, hoses, and miscellaneous objects, such as fuel racks that had been placed in the basins. In total, workers removed nearly 400 tons of additional material from the K-basins. The debris was placed in large metal boxes and disposed in Hanford's large, lined waste disposal facility, the Environmental Restoration Disposal Facility, or ERDIF. Workers were involved in every step of planning and executing the sludge and debris removal work, including designing an array of new tools and processes. Despite the novelty and the difficulty of the work, workers maintain an impressive safety record. Active employee safety councils worked with management to make safety a priority. By 2007, Fluor's K-Basin's personnel had worked nearly 4 million hours without a day lost to an injury. With the fuel, sludge, and debris out of the K-East basin, Fluor began work to tear down the superstructure and eventually excavate the basin itself. First, Fluor emptied some water to allow a 14-inch layer of grout to be poured onto the basin's floor. The grout provided a shield to reduce the radiation and worker exposure. Then the rest of the water was pumped out of the basin into tanker trucks. It took more than 200 tanker truckloads to remove all the water. The radioactive water was treated and then safely disposed according to permitted standards. Sand was then poured in to provide an additional shield from the remaining radiation. The sand was also a foundation for large demolition equipment. In April 2008, for the first time in 50 years, Hanford's K East Basin was no longer listed as a nuclear facility. This change in status signified that all the nuclear material had been removed, eliminating the potential for any nuclear-related incidents. Fluor then used an excavator and other demolition tools to remove the basin's superstructure. It completed the work in September 2008, disposing of the rubble in Erdif. With the superstructure down, the stage was set for removing the concrete basin and remediating the soil underneath. Fluor's K-Basin's cleanup work was indeed a huge step in protecting the Columbia River, the region, and the people of the Pacific Northwest. The plutonium finishing plant, known as PFP, was Fluor's other most significant cleanup project at Hanford. The 40 years during the Cold War, workers at PFP performed the final step in manufacturing plutonium for nuclear weapons for the United States. The facility received concentrated liquid solutions containing plutonium and converted them to plutonium metal for warheads. The conversion or finishing process involved heat and corrosive chemicals. Significant amounts of radioactivity and radiation were present in PFP. Plutonium finishing operations took place in PFP's main building in a long, interconnected series of steel containers designed to hold highly radioactive materials. The average size of these glove boxes was about 2/3 that of a standard sports utility vehicle. Glove boxes have windows and round openings in their sides. The openings are fitted with arm-length gloves made of heavy plastic. Using these gloves, workers standing outside the boxes reached in and performed tasks. Over the years, many additional facilities were built inside PFP's special fenced area, known as the PFP complex. Eventually, this complex had 3 laboratories, plutonium recycling and waste handling facilities, and various support structures. When Fluor arrived at Hanford, a federal safety board had ordered PFP to stabilize and repackage nearly 20 tons of leftover plutonium-bearing materials in the complex. The work was behind schedule and not going well. Fluor conducted safety reviews and redesigned processes to work with the very dangerous, unusual materials. It then restarted the work and finished the stabilization and packaging project in 2004. Fluor's work at PFP greatly reduced radiological risks in the plant and lowered the potential for terrorists to acquire the materials. The project beat all progress milestones and finished under budget. In the process, PFP became the first high-hazard nuclear facility in the nation to be awarded the prestigious star status in the Department of Energy's Voluntary Protection Program, VPP, a safety system like that of the Occupational Safety and Health Administration, OSHA. Facilities earning star status have comprehensive safety programs, involved workers, and among the lowest injury rates in the complex. Star status means the accident and injury rates in a project remained at or lower than industry standards for 3 years in a row. FluorHanford led the entire DOE complex in having 8 of its major projects, plus the affiliated Fluor Government Group office in Richland, attain VPP star status. Overall, FluorHanford reduced OSHA recordable injury rates by 75% during its tenure at the site. Fluor's PFP stabilization and packaging project won many awards, including the Columbia River Basin Project Management Institute's Project of the Year in 2004, and honorable mention in the Department of Energy's Secretarial Award of Achievement. Even before the stabilization and packaging project ended, Fluor began decontaminating and demolishing, that is, performing D&D, at the PFP complex. The main PFP building is almost as long as 2 football fields and nearly 50 feet tall. It held 189 glove boxes contaminated with plutonium, thousands of feet of ventilation ducting and process areas, miles of piping, and thousands of valves, pumps, tanks, and other miscellaneous equipment. FluorHanford removed much of the plutonium powder and sludge that had collected or held up in facilities, equipment, pipes, and ductwork. It was slow and difficult work. Workers had to wear special bulky suits, often 2 at a time, to protect them from radioactivity. Often they also had to breathe through hoods, hoses, and bottles of fresh air. They usually wore 2 or more pairs of gloves, making it hard to grip tools. Next, Fluor began removing contaminated equipment from PFP's glove boxes. Cleaning out the glove boxes was challenging because many areas were very cramped and extremely contaminated. The inside surfaces of the glove boxes were embedded with contamination, and heat and acids from plutonium processing had clouded the plastic windows. Equipment inside the boxes had sharp edges that could puncture gloves and waste bags. Reaching into the glove boxes, workers carefully disconnected, cut up, and removed contaminated equipment. They used powerful solutions to clean or decontaminate the insides of the boxes. In total, they completed nearly 100 glove boxes in the main PFP facility. Among Fluor's most important activities at PFP was cleaning out and tearing down an incinerator and liquid waste treatment facility. The small 232Z incinerator building was extremely contaminated with plutonium ash when FluorHanford crews first tackled cleanout. One room in the building, the scrubber cell, had higher contamination levels than any other building that had been demolished in the United States. The work had to be carefully planned and executed with painstaking precision because the incinerator building was wedged among 3 facilities with ongoing operations and more than 600 workers. But again, workers succeeded, tearing down the facility and shipping out the debris and rubble. Today, a clean gravel-covered concrete slab now overlays the footprint where the 232Z facility used to stand. The highly contaminated 241Z liquid waste facility posed its own set of challenges, particularly 5 large steel tanks in concrete pits under the building. The tanks once held liquid waste with plutonium and chemicals from PFP. One tank had leaked liquids into the pit, and pieces of contaminated equipment had been discarded in all of them. To clean out the pits and tanks, workers wearing bulky protective clothing and breathing equipment had to climb down ladders through narrow manholes. In the end, they packaged and removed nearly 4 tons of contaminated waste. They also removed an 800-pound overflow tank. With the tanks and pits emptied, FluorHanford tore down the building. The planning was so precise that the structure was safely brought down in just 3 weeks. Removing the rubble and stabilizing the site took just 3 more weeks. In addition, Fluor demolished 20 other structures at PFP and began cleaning out another, the plutonium reclamation facility that had handled highly radioactive waste products. In 2007, at DOE's direction, Fluor began shipping Hanford's plutonium inventory to another site. Workers meticulously inspected and tested the shipping containers and helped to ensure that the strict requirements were met for fabricating additional containers. The PFP complex at Hanford was once considered one of the 5 most hazardous facilities in the DOE's complex. Fluor cleanout and D&D work made PFP much safer and less contaminated, taking it off DOE's high-risk list. At the same time risks were being eliminated at the K-Basins and at PFP, Fluor was also working in another area of Hanford called the Central Plateau. The plateau is an egg-shaped area approximately 70 square miles in the middle of the site. It contains Hanford's radiochemical reprocessing plants, the 200 East and 200 West areas, and includes the most radioactive waste and contaminated facilities on the site. The Central Plateau has 5 large radiochemical processing facilities, or canyons, and more than 900 other buildings. It also encompasses more than 880 soil waste sites and 177 underground waste tanks. The waste tanks were managed in a separate work scope managed by another contractor. In 2004, Fluor's D&D project developed and organized a roadmap to clean up Central Hanford. The Central Plateau Closure Plan grouped cleanup work to be completed over the next several decades into 22 closure zones. Within those zones, about 4,000 tasks needed attention. In 2005, FluorHanford's D&D project achieved a major success when the EPA approved the first record of decision for disposing of Hanford Canyon. The plan was for the World War II U-plant. Fluor's D&D project also wrote a multi-canyon project management plan that outlined a path to dispose of 3 other canyons: Purex Plutonium Uranium Extraction Plant, the B Plant, and the Redox Reduction Oxidation Facility. Disposing of Hanford's canyons will be a very long process. In the meantime, the canyons had to be maintained in a safe state to protect the environment. At the Redox facility and the U-plant, FluorHanford engineers and workers teamed to replace massive fans, filters, and other equipment that was 55 to 65 years old. These and other major repairs extended the life of the canyons while they wait for disposal. FluorHanford's D&D project also pioneered a technique called open-air demolition in tearing down buildings contaminated with plutonium. With the proper planning and a skilled workforce, the novel approach can be done safely and saves time and money. The process involves removing some contamination and then gluing the rest of the inside surfaces of the building. The D&D project first tackled the 233S plutonium concentration facility. Engineers modeled air circulation in and around the structure and established contamination and buffer perimeters. Crews then applied fixatives to the interior surfaces of the building. They sprayed a wet mist from a fog cannon on outer walls of the building and mounted other misters on some tools. This mist wetted down the dust so that it would not travel outward and spread contamination. Close to the building, workers wore special clothing to protect them from radioactive contamination. They often breathed through masks that supplied them with fresh or filtered air. FluorHanford and regulatory agencies checked the air monitors and verified that contamination had not spread outside the designated zone. As they tore down 233S and removed all the contaminated rubble, workers entered the contamination zone more than 4,000 times without a single recordable injury or skin contamination. But 233S was just the beginning. Fluor demolished nearly 150 other aging Hanford buildings that had no further use. While these structures were not necessarily radioactively contaminated, they often contained hazardous materials such as asbestos. Fluor also prepared other facilities for future demolition. The D&D project cleaned out a contaminated World War II structure. The 212N facility was not ready to be torn down, but needed to be cleaned out to make it safer and cheaper to manage. Large wooden crates containing contaminated glove boxes were tightly packed inside the building. Huge quantities of thick insulation were packed around the crates, and steel walls and partitions were built around them. Crews worked for a year to carefully remove the insulation and partitions, and carefully ease the crates out of the building. Some crates were so deteriorated that they had to be repackaged before they were moved. Despite all the challenges, Fluor removed all of the crates and reduced surveillance costs on the building. Indeed, the company changed the skyline of the Hanford site and did it safely. Under the Hanford site, about 100 square miles of groundwater or aquifer contain radionuclides and hazardous chemicals. The aquifer is not used for drinking water. However, protecting the Columbia River should the contaminants migrate is important. Fluor managed Hanford's soil and groundwater remediation project from 2002 through 2008. Contamination in Hanford's soil and groundwater came from producing plutonium for nuclear weapons from 1944 to 1989. During those years, site facilities discharged about 450 billion gallons of contaminated liquids to the soil. At Hanford, the depth of the soil column varies from 30 to 80 feet near the Columbia River to more than 400 feet in some parts of the Central Plateau. In addition, about 120 million gallons of very radioactive liquids were stored in 177 underground tanks, some of which leaked. Some of the leaked liquids remained in the soil, while some reached the groundwater. FluorHanford's soil and groundwater remediation project operated 7 major systems to treat the groundwater, enlarging 3 of them. These systems pumped out concentrated plumes of contamination in the groundwater, treated them to remove contaminants, and returned the water to the aquifer. For example, a pump-and-treat system in the Central Plateau removed thousands of pounds of carbon tetrachloride. The project also researched and installed systems to test ways to chemically change or bind the contaminants in the groundwater. By 2008, more than 3.6 billion gallons of contaminated groundwater had been treated. Fluor also drilled new wells to extract groundwater contaminated with technetium-99 and uranium. During the 6 years that Fluor managed the soil and groundwater project, workers drilled more than 250 new wells. Fluor's soil and groundwater project also decommissioned more than 550 older wells that could have served as pathways for contamination to reach the groundwater. Most wells were decommissioned by sealing them with special cement called grout. In some cases, Fluor had to use explosives to perforate wells with double or triple casings and then fill them with grout. Hanford's reactor areas, known as the 100 areas, border some of the most important areas for spawning salmon in the continental United States. During weapons production, Hanford's 9 massive reactors stretched across approximately 13 miles of Columbia River shoreline. These reactors used water from the river for cooling. 8 of the reactors added a chemical called sodium dichromate to help control corrosion in piping. Over the years, sodium dichromate leaked into the soil and groundwater. Chromium from this compound is extremely toxic, and in the form of chromium-6 travels and mixes easily in water. FluorHanford led an engineering effort to clean up the plumes of chromium-6. It operated and expanded treatment systems that changed the chromium-6 to chromium-3, a form less harmful to living organisms. Fluor's pump-and-treat systems in the reactor areas removed nearly 2,000 pounds of chromium-6 and processed millions of gallons of water. At the 100N area, strontium-90, a byproduct of reactor operations, was leaching into the groundwater and concentrating at levels more than 1,000 times those allowed in drinking water. In a unique endeavor, Fluor scientists and engineers installed a new system of wells along 300 feet of river shore in the 100N area. They injected the wells with a calcium phosphate compound that bound the strontium in place long enough for its radioactivity to decay. Millions of uranium fuel assemblies for Hanford's reactors were made in the 300 area, also along the Columbia River. Uranium contamination is pervasive in the groundwater and soil in this region. Fluor crews installed small, flexible aquifer tubes at the river's edge to sample and measure the uranium near the river. Soil waste was another challenge that Fluor addressed. Between 1945 and 1987, 7 major ponds received approximately 213 billion gallons of contaminated liquids from facilities in the Central Plateau. This waste could move downward and worsen groundwater contamination. However, in some cases, contaminants might not move substantially or might not move until after they decay to harmless levels. To target cleanup efforts and use funding wisely, FluorHanford scientists extensively investigated soil wastes and soil columns. They also probed solid waste buried in trenches and more than 100 miles of old pipelines. They drilled hundreds of boreholes and inserted various types of probes into the soil to understand the extent and types of contamination. In 2006, to examine a crucial area of carbon tetrachloride contamination, Fluor used a technology that had never been applied in a high radiation environment at Hanford. Workers drilled under the Z9 crib on an angle, creating a slanted borehole, A crib is a historical Hanford term for an unlined liquid disposal site in the soil. Drilling equipment could not be set directly on top of the Z9 crib because its cover was not strong enough to hold it. Soil and vapor samples were collected. Floor workers wearing protective clothing carefully shielded and packaged the samples as they were withdrawn from the ground. They placed the samples into a specially built enclosure to ensure safety. FluorHanford scientists and workers paid close attention to chain of custody requirements in handling the samples. Chain of custody means that paperwork follows and verifies each step, from labeling to transporting, storing, and analyzing the sample. In 2007 alone, Hanford's field sampling program collected nearly 70,000 sample bottles from the site wells, totaling 13,000 gallons of water. This number was in addition to several hundred soil samples. In addition to sampling, Hanford scientists and engineers mapped several underground areas by passing an electrical current through the soil. This technique is called electrical resistivity scanning. It provides information about moisture and helps find underground areas of high contamination. After these surveys were done, Fluor drilled boreholes to confirm the presence of contamination. FluorHanford's soil and groundwater remediation project also employed other state-of-the-art methods to gather data about the layers of basalt, clay, and sand beneath the site. They obtained data by bouncing sonic waves or pulses against the deep layers. In addition, a helicopter collected airborne electromagnetic survey data as it flew over the areas of contaminated groundwater. Airborne electromagnetic data can reveal differences in subsurface formations. This data helped Fluor scientists look for evidence of channels in the hard basalt where contaminated groundwater might travel faster toward the Columbia River. Protecting the magnificent Columbia River is important to all Hanford site neighbors, stakeholders, regulators, Indian nations, employees, and others. Fluor provided data gathered from sampling and mapping groundwater and soil contaminants to DOE to share with the public in libraries. Fluor also organized workshops and open meetings where interested persons could learn the results of sampling efforts, provide their views about remediation, and express their opinions about new technologies. The Waste Stabilization and Disposition WSD project was another very significant FluorHanford cleanup project. It operated 10 major solid and liquid processing and analytical facilities to deal with radioactive and/or hazardous wastes. One part of the project encompassed a waste storage complex of more than 50 buildings. Fluor's WSD project also provided services to other contractors who generated waste at the Hanford site during the course of their operations. WSD helped those contractors document and package waste correctly so it could meet the necessary requirements for disposal. At Hanford, solid waste burial grounds are separated based on when the wastes were generated, before 1970 and after 1970. Fluor managed the majority of Hanford's burial grounds for transuranic true waste generated after 1970. True is the most radioactive form of solid waste and is often contaminated with plutonium. Fluor also managed burial grounds containing nearly 1 million cubic yards of low-level waste material and some mixed low-level waste that was also contaminated with chemicals. Every year, Fluor's WSD processing facilities treated millions of gallons of contaminated liquids from across the Hanford site. During Fluor's years at Hanford, it processed nearly 4 billion gallons of contaminated liquids through effluent treatment facilities. WSD also safely stored the 2 most highly radioactive consolidated waste collections on the Hanford site, nearly 2,000 capsules of extremely radioactive cesium and strontium at the Waste Encapsulation and Storage Facility, and nearly 4.5 million pounds of spent nuclear fuel at the Canister Storage Building. In total, Fluor's WSD project safely stored approximately 40% of the radioactivity at the Hanford site in these 2 facilities. In its first year at Hanford, Fluor initiated operations of the Waste Receiving and Processing Facility, or WRAP, a unique facility. RWC combined more solid waste handling functions under one roof in an integrated program than any other facility in the United States. Its main function was to prepare true waste for shipment and permanent disposal at the Waste Isolation Pilot Plant, or WIP, in New Mexico, about 1,800 miles south of the Hanford site. Fluor workers remotely opened waste containers in RWC's glove boxes to remove non-permitted items and repackage damaged or corroded drums. Hanford's True program was certified through WIP's rigorous process soon after WIP opened. Beginning in 2000, Fluor's WSD project shipped more than 400 loads of True waste, totaling about 4,000 cubic yards, to WIP. The shipments to WIP are the only radioactive waste loads to leave the Hanford site since cleanup began. In 2003, Fluor began digging up approximately 38,000 drums and boxes of waste suspected of being True but stored in low-level waste trenches at Hanford. This amount of waste is enough to fill about 76,000 standard 55-gallon drums. The waste also had to be characterized, and the final disposition determined and accomplished. In addition, Fluor began characterizing and disposing 40,000 drum equivalents of waste suspected to be True that was stored above ground in facilities. This waste presented huge challenges, including badly degraded waste containers. However, Fluor met or beat all retrieval and shipping milestones throughout the rest of its time at Hanford. By the time Fluor's contract expired in 2008, it had retrieved nearly 40% of the buried waste. In another crucial success, Fluor's WSD project treated the first portion of sludge from the K-basins in 2006. This hardened sludge was the first fuel basin sludge ever treated in Hanford's history. The sprawling 586 square mile Hanford site was built by the Manhattan Project in World War II. By the late 1990s, its roads, utilities, pipelines, and telecommunication systems were 55 to 65 years old. They were not designed to function into the 21st century, yet they needed to support a prolonged cleanup mission. Fluor's challenge was to maintain and upgrade this infrastructure, provide uninterrupted and high-quality service, and not spend money on non-essential repairs. Fluor carefully maintained essential services while allowing some aging structures to degrade in a monitored fashion. Fluor shut down 3 large coal-fired steam plants dating from the 1940s and replaced them with small packaged boilers geared to specific needs of site facilities. Fluor also closed 2 water filter plants and streamlined electrical utility services. It pioneered a technique called mortar lining to reline portions of Hanford's water system to prevent leaks. This environmentally friendly repair won a DOE 2004 Pollution Prevention Best in Class Award and was nominated for EPA Champions for Environmental Leadership and Green Government Innovation Awards. Fluor Site Services Group also won other awards, including a World Safety Organization Concerned Corporation Company Award and 2 Hammer Awards from Vice President Al Gore for streamlining government operations. It also won a FluorHanford Environmental Stewardship Award and a DOE Executive Award for Leadership and Innovation. Special parts of Fluor's site-wide operations included managing Hanford's fire department, a special security patrol force, and site emergency response services. Under Fluor, the Hanford Fire Department received DOE's top honor for fire protection, the Walter W. Mabee Award. In 2000, FluorHanford's fire department, along with other regional fire departments, successfully battled a huge wildfire that raced over 192,000 acres in 2 days. The firefighters kept the fire from reaching any nuclear facilities. Under Fluor, Hanford Patrol won hundreds of awards and prizes for marksmanship and other skills. One FluorHanford Patrol officer has been the top gun, best sharpshooter in Washington State for 27 years in a row. During 2000 to 2002, Fluor restructured the functional organizations to support the cleanup projects. The company reallocated direct funding to project support services. This approach reduced administrative costs and work process complexity and ensured the appropriate level of site operating infrastructure was in place to support the long-term cleanup schedule. Indirect costs and staffing were reduced by 26%, more than $200 million per year, and the savings were invested into the projects, thus accomplishing more cleanup. Fluor initiatives such as the Enterprise Resources Process Solution, the Requirements Reduction Initiative, and a streamlined procurement process gained for the company one of the most efficient business systems in the DOE complex. Shortly after coming to Hanford, Fluor opened and began operating the Hazardous Materials Management and Emergency Response, or HAMMER, Training and Education Center. At the 80-acre HAMMER campus, Hanford's workers, as well as emergency responders, border guards, and customs agents from around the world, trained in unique and realistic settings. HAMMER was legendary for providing training as real as it gets during the 11 years that Fluor operated HAMMER. It conducted approximately 400,000 student days of training. John Sweeney, president of the American Federation of Labor, Congress of Industrial Organizations Building and Construction Trades Department, said that HAMMER was one of the most important partnerships of labor and management in this country. HAMMER's strong partnership with labor contributed to Fluor's many successes at Hanford. During its tenure at Hanford, Fluor managed a large sodium-cooled nuclear reactor that was designed to test various materials, fuel, and processes. The Flux Test Facility, or FFTF, was not operating during Fluor's early years at Hanford while its future was being debated. With the reactor's future mission uncertain, Fluor maintained FFTF in a safe condition and conducted multiple tours, organized public meetings, and presented information to support the debate. After DOE decided to permanently close FFTF, Fluor began D&D. Workers drained thousands of gallons of radioactively contaminated sodium, packaged and shipped spent nuclear fuel, and drilled into the reactor's core vessel to drain residual molten sodium. They also deactivated many ancillary facilities and equipment tainted with radioactivity, polychlorinated biphenyls, chemicals, and other hazardous substances. In every FluorHanford project, safety came first. Much of Fluor's work was done outdoors, where dangers came from industrial hazards, weather, insects, and other desert inhabitants, radioactivity, and distance from established facilities. Other work was done in extremely cramped quarters in contaminated and aged facilities that did not meet modern safety codes. Yet Fluor achieved an astounding safety record at Hanford. In fact, the recordable injury rate, as measured by OSHA, decreased by nearly six-fold. Rates in days away from work and days restricted from work also dropped dramatically. In every way, Fluor showed its employees that safety was job one. Every single meeting began with a safety topic. Zero accident councils led by workers with management participation operated in every major Fluor facility and project, and a President's Zero Accident Council met monthly to review every accident. Fluor wrote the first integrated safety management system program on the Hanford site in 1997. As part of this program, every Fluor worker had stop work authority and responsibility for any job if he or she believed the work was being or would be performed in an unsafe manner. Fluor introduced the bargaining unit safety representative concept during its first year of the contract with the Hanford Atomic Metal Trades Council, HAMTEC, the Hanford Guards Union, and the Building Construction and Trades Council. The 11 FluorHanford safety representatives provided a unique and highly effective avenue to communicate and resolve employee safety concerns. The program reaped a multitude of benefits and was adopted by other Hanford contractors. The Safety Representative Program flourished and was a key component in Fluor's success. This program was adopted by the new 3 prime contractors currently working at Hanford today. Fluor demonstrated strong knowledge of management by perfecting the ALARA Center of Excellence. ALARA stands for As Low as Reasonably Achievable and means that all work and to keep exposures to radiation as low as possible. Under Fluor, the ALARA Center grew to become a multi-purpose national resource center that found and demonstrated products and invented first-of-a-kind solutions to execute work safely with less exposure to hazards. Similarly, under Fluor, a rudimentary work hazards analysis system developed into a sophisticated yet user-friendly award-winning program that also attracted the attention of organizations outside the nuclear industry, such as the National Aeronautics and Space Administration. The Automated Job Hazards Analysis Program is a computerized tool that evaluated the potential risks of every job and presented ways to work more safely. In addition, through the Radiological Control Center of Expertise that it established at Hanford, Fluor lowered the number of skin contaminations by 33% in 9 years. Fluor expanded its commitment to safety into the community in a large public safety exposition held every year. Fluor's attention to safety at Hanford and in the community did not go unnoticed. Recognition included being named one of America's 10 safest companies by Occupational Hazards magazine in 2006, being featured in Occupational Health and Safety magazine for ergonomic improvements at the K-Basins, earning awards from the Association of Washington Business for being a safe workplace, and being interviewed by Inc. magazine for a story on best safety practices. Perhaps the crowning achievement was winning the National Safety Council's prestigious Robert W. Campbell Award for Safety in 2008. This award highlighted how Fluor greatly improved safety by involving workers, having active engagement by union safety representatives and union-led safety councils, and sponsoring workers training workers classes at the Hammer Center. Safety is the first word in Fluor's business values: safety, integrity, teamwork, and excellence. The corporation operates on the fundamental premise that work can and must be done without adversely affecting the safety and health of employees, subcontractors, local communities, and the environment. In fact, as Fluor's chairman and CEO Alan Beckman puts it, we hold sacred the well-being of people, employees, customers, and communities in which we live and work. Global stewardship is a responsibility, our privilege. In addition to changing the Hanford skyline and leaving the site safer than when it came, Fluor also made its mark in the community. Fluor was the largest contributor to the local United Way during its years at Hanford. Fluor and its employees donated more than $9.2 million. Fluor's community involvement team contributed enormous time and effort, leading more than 300 volunteer community projects. In these projects, Fluor employees donated approximately 32,340 hours, conservatively valued at nearly $600,000. In addition, Fluor managed a great deal of DOE's interactions with the Hanford Advisory Board, or HAB, a large and diverse collection of Hanford stakeholders and interested parties. Fluor worked with the HAB to identify and address stakeholders' concerns and keep the cleanup moving forward. Fluor also managed a record number of tours of the Hanford site for DOE. Fluor grew a very small public tours program up to one that provided 60 site-wide tours per year, serving nearly 3,000 visitors each year without any significant safety incidents. The program's web-based registration system and other features became a model for other DOE sites. From improving safety performance to overcoming technical challenges. From improving the site's infrastructure to setting the standard for community involvement, Fluor made a discernible difference at Hanford. It brought innovative approaches and enduring solutions to make the site cleaner and safer, and the Mid-Columbia region of Washington State a better place to live.